Good morning, everyone. Welcome to the class. Very good morning, one and all. Yes. Let us get into the most important topic from digital circuits. Venkana, if it is possible, right? I do that before you ask itself, right? If it is available, if we are getting, sure, I do, right? So functionality is sufficient. Understand correctly, Venkana, right? Yesterday, someone was asking me a question. The minimum number of 4 to 16 decoders required to implement a 10 to 1024 decoder. Question is a minimum number of 4 to 16 decoders required to implement a 10 to 1024 decoder is dash. That is the question. Question once again, the minimum number of 4 to 16 decoders required to implement a 10 inputs to 1024 decoder is dash. Please try this in 2 minutes. Yes, yes, Abhinesh. Right. If you want to know the question once again, the minimum number of 4 to 16 decoders required to implement 10 to 1024, 10 inputs to 2 power 10 is 1024 decoder is dash. Shivalila, one more is required. Check it. Manisha, you are doing a mistake. Right. Lal Krishna. Right. Simple thing, how to proceed for these type of questions is using number of variables A, B, C, D, E, F, G, H, I, J. These many variables. No doubt, 1024 outputs means how many number of 4 to 16 decoders required in the end stage. How many number of 4 to 16 decoder, because each 4 to 16 decoder can produce 16 outputs means and the end stage to produce 1024 outputs, how many it is required? 64. Am I right? 64. The 64 can be enabled, or the 64 4 to 16 decoders are using last 4 as inputs. right? To enable the 64 4 to 16 decoders, I need to use 64 lines. 64 lines. To produce 64 lines, how many number of 4 to 16 decoders required? 4. So those 4 are using input variables are these. That means there is a last stage. Last before stage, what we can have? Right. 4 number of 4 to 16 decoders are sufficient to enable 64 number of 4 to 16 decoders which are in end stage. So how many decoders are there in the second stage? 4 number of 4 to 16 decoders are there. To enable these, what we can use? First stage. Here I am constructing 4 to 16 decoder. Using 4 to 16 decoder, I need to construct a 2 to 4 decoder. I need to construct 4 decoder. So here we have only 2 inputs remaining. These 2 should be used as inputs. Now I need to produce 2 to 4 decoder. Required optimally 2 to 4 decoder. But here I use 4 to 16 decoder only. I have 4 to 16 decoder. In that I want to use only 2 inputs. Then how it can be constructed? Let us see. Here we have 4 inputs. Here we have 4 inputs. And so here we have 16 outputs. But what we need here, we need to use only 4 outputs. Let me say that 0, 0, A, B. Then what we get here? For AB 0, 0, this is enabled. For AB 0, 1, this is there. For AB 1, 0, this is there. For AB 1, 1, this is there. What I'm doing here, I'm constructing a 2 to 4 decoder using 4 to 16 decoder. This is one possibility. I can go with the different possibilities also. When AB is 0, 0, all zeros, then here if I say Z0 to Z15, because we have 16 outputs. Now I use that AB 0, 0, then Z0 is 1, AB 0, 1, Z1 is 1, AB 1, 0, Z2 is 1, AB 1, 1, Z3 is 1. Z3 is 1. So these are what is here using 4 to 16 decoder. Using 4 to 16 decoder, I am constructing 2 to 4 decoder which is required in the first stage. So I'm using one more 4 to 16 decoder to construct a 2 to 4 decoder. So 1 plus 4 plus 64. Don't forget this one. Don't forget this one. Otherwise, it must be specified. There are decoders which are having that to enable signals. So it must be specified, right? There are decoders with to enable signals. Then you may be going with other possibilities by using that select, right? Enable signals or AB for these 4 number of 2 to 4 decoders by applying that A bar, B bar, A bar, B, A, B bar, A, B. Again, I'm using inverters here. So if it is not allowed to use any additional logic gates, additional circuitry is not allowed. I need to use only 4 to 16 decoders. Then I should go with this type of implementation only. If it is allowed to use, only 4 to 16 decoders, then we have to implement what is it here 2 to 4 decoder using 4 to 16 decoder. So that is required. So here I'm showing that how it is possible to construct a lower order from higher order also. Already we have done this on multiplexer. Similarly on decoder also. Whenever it is required to construct lower order from higher order, this is the way we can use. So by connecting that respective inputs to respective order, if I say this one is MSB, this one is LSB, this is possible. You can change that. Then what happens here? It may be getting that, for example, I'm using that A, B, 0, 0. Then what happens here? 0, 0, 0, 0, 0, 1, 0, 0, and 1, 0, 0, 0, and 1, 1, 0, 0. Am I right? If I use AB on MSB lines, then what happens here? I need to use Z0 I need to use Z4, I need to use Z8, I need to use Z15. Understand correctly? Depending on order we have used on inputs, I need to use respective output line. What about remaining? All are zeros always. So we need to use respective output line as enable signals of 4 number of 4 to 16 decoders. In second stage, we have 4 number of 4 to 16 decoders. 4 number of 4 to 16 decoders. For that, what we are using here? Respective output line should be used as enable signal. That depends on what order I'm using. Some of you may be saying that 0A, 0B I use. Your wish. Instead of using 0, 0, I can use 1, 1 also. If I use, for example, if I use 1, 1 here, understand correctly. If I use a 1, 1, if it is 1, 1, what is that here? Possibilities 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Which are the output line should be used as enable signals of 4 number of 4 to 16 decoders? I need to use Z12, Z13, Z14, Z15. I'm using that Z as output internally. So 12 to 15 I need to use. Depending on what we are considering, what order we are considering, and what is the other input signals also. Other input signals also. Depending on that, we have to choose respective output line as enable signal of this 4 to 16 decoders in the second stage. So that will be the answer. Check it correctly. Yes. Now you might have understood correctly. Just a minute. Think logically, you can get expected answers. Yes, it is 69. Yeah, you can try in any number of ways, but finally it has to meet right expected function. Yes, Pratyush. Yes. No. Minimum when it is asked, you need to go with 69 only. Sivalila. Minimum number of 4 to 16 decoders required to implement this is now 69. Now we are ready for most important topic for our competitive exams, and most of the students feel difficult this topic in the entire digital circuits. People are escaping or hands up in sequential circuits because the level of questions are very different. And earlier questions simply just counter examples or counter sequence and so and so. But nowadays questions are very different. How we have been getting questions, let us see, and how to answer those questions in less time. Let us try all these. So now heading is sequential circuits. What is sequential circuits? Output depends on what we discussed. The output depends on present input and past output. With this only, we have concluded one more statement. Once again, output depends on present input and past output. From this statement, we derived another definition for sequential circuits. What is that here? Past output depends on past inputs and past to past output. Past to past output is depending on past to past inputs and past to past output. So, and so on. That means from the system reset condition, what is the order we are applying input combinations? What is the sequence we are applying input combinations is deciding system output. So, it can be named as a sequential circuit. As output depends on sequence of input combinations, so it is named as a sequential circuit. So order of the input combinations can decide the system output. The sequence of input combinations can decide the system output. So it is named as a sequential circuit. So on input terminals, we are applying input combinations one by one. On input terminals or input ports, wherever we are applying input combinations. Arpit, it's a memory concept. Programmable logic array. Programmable array logic. Read only memory. Flash memories. SRAM, DRAM. Separately, I'm going to discuss in memories. Semiconductor memories, we have a separate chapter. Arpit Anand. Please let me follow my sequence. I will cover everything. No need to worry. I will cover everything. No need to worry. Right. Sequential circuits. So what we discussed here is a output depends on sequence of input combinations. So it is named as a sequential circuits. That means for a system, we have input terminals where we are applying input combinations one by one. Where we are applying that input combination one by one. When we are applying that a new input combinations on the same terminals, it is overwriting existing combination. So already there was input combination and I'm applying a new input combination. That means when you are applying new input combination on same terminals, yes, it is overwriting existing. But system needs what was applied earlier also. To respond to this inputs, it should know what was applied earlier. That means system has to remember what was applied earlier also. Somehow system has to know what is applied previously. But on the input terminals, we have only one input combination which is applied at this present only. But system has to know what was applied earlier also. For that, system has to remember. Then we say system needs memory elements. Point should be understood correctly. When we are saying that sequence of input combinations must be known to say what is the output. That means when you are applying a new input combination presently, what was applied earlier also should be known to the system to say correct output or to give correct output. It needs what was applied earlier also. For that, system needs a memory element. Because it has to remember what was applied earlier also. So system need memory element. What is memory element? A circuit which is capable of remembering 1-bit data is called 1-bit memory element. Point should be understood correctly. I have been trying to convey the concepts in a sequence. The sequence must be understood correctly. So every topic I follow a sequence. Even when I started about number systems also, when I'm introducing some concepts, sure, those will be useful in the next step. So don't think that why it is here. No, I've been following a perfect sequence. Follow that correctly. So the way I'm narrating also, you need to follow correctly. So where we are getting that importance of each and every point should be discussed. If I discuss directly, may not be getting that why you have been studying that. There is right? So on the input terminals where I'm applying input combinations one by one, it is not having all the input combinations previously applied. That is the reason system has to remember what is applied earlier also. For this, system needs a memory element. System needs a memory element. What is memory element? A circuit which is capable of remembering one bit data is called a one bit memory element. A circuit which is capable of remembering one bit data is called a one bit memory element. What do you mean by remembering? If it is given a 0, it remains in 0 until I disturb the circuit. Circuit is capable of remembering one bit data. That data may be 0 or 1. If I give a 0, it must be remaining in 0 until I disturb the circuit. If I give a logic 1 to the circuit until I disturb the circuit once again, so it must be remaining in 1 only. What do you mean by memory element? A circuit which is capable of remembering one bit data is called one bit memory element. The data may be 0 or 1. If I give a 0, it must be remaining in 0. If I give a 1, it must be remaining in 1. That's what we are expecting here. 0 should be remembered, 1 should be remembered. What is the circuit we can have? Let us see. What is here? What is the circuit we can have? Let us see. So what we are seeing here, it is a one bit memory element which is capable of remembering one bit data. Is nothing but 0 must be remembered, 1 must be remembered. Remembering is nothing but it should not be changing on its own, it must be remaining in the same. For that, I can say let me consider this circuit. We understand more about this. Pranita, yes, I'll do. A question hour will be there. Please wait. I'm in a flow. Let me continue. Right? See, what is it here? I'm using a circuit like this. What is it here? Two inverters connected like this in a ring circuit. In this, what happens? Let us see. If it is a 0, what is it here? It is 1, and again it is 0. What is here? It is 0 and 1, and again 0. Then what we say here? This port was at 0, logic 0. That means it will be remaining in 0 only. This port was at logic 0. Then it is remaining in 0 only. Until I disturb the circuit, it will be remaining in 0 only. For example, on the same terminal, if it is 1, what is it here? 0. It is 1. That means it is remaining in 1 only. That means 0 is not changing on its own. It is remaining in 0 only. 1 is also remaining in 1 only until we disturb the circuit. That means what we can say, 0 is stable, 1 is also stable. 0 is stable, 1 is also stable. That means 0 is remaining in 0 only until I disturb the circuit. If it is 1, it is remaining in 1 only until I disturb the circuit. That means 0 is stable and 1 is also stable. This circuit is called a bistable circuit. Directly they have been framing questions, sir. The circuit is a, right? Understand correctly. Directly they are framing questions, sir. So the points also must be understood. It is having two stable states. The two stable state condition is nothing but a bistable condition. It is called a bistable circuit. It is called bistable circuit. I hope you are following. It is a bistable circuit because 0 is stable, 1 is stable, two stable states. So it is named as a bistable circuit. And you might have studied in your linear IC applications in your graduation. In your graduation, you might have observed a bistable multi-vibrator. When coming to applications, first application is a memory element because it is stable in logic 0, it is stable in logic 1. That's what is required for memory element also. 0 must be remembered, 1 must be remembered. That is the reason both 0 and 1 are stable states. That is called bistable circuit. That is called bistable circuit. Once again, it is a bistable circuit in which 0 is stable as well as 1 is also stable. 1 is also stable. Now, I can redraw this circuit. Let me consider here. If it is the inverter 1, inverter 2. Let me draw these two inverters in parallel. Let me complete the connections also. What is it here? Output of I1 is connected to, if I say it is I1 and it is I2. Output of I1 is connected to input of I2. Output of I1 is connected to input of I2 and output of I2 is connected to input of I1. Let me complete those connections, sir. Output of I1 is connected to input of I2. Output of I2 is connected to input of I1. Cross coupling. Cross coupling. So I have drawn the same circuit. For example, if it is X here, it must be X bar. What do you mean with it? If it is 0, it becomes 1. If it is 1, it must be a 0. What is here? If X is 0, X bar is 1. If X is 1, X bar is 0. So these two must be always complementary. To work it as a bistable in this circuit, these two must be always complementary. So what is the problems in this? All these we understand later. Before understanding this, let me discuss one more thing. Let me discuss one more thing. What is it here? In this ring circuit, instead of using two inverters, if I use three inverters in this ring circuit, instead of using two inverters, I'm using three inverters. Let us see what happens. If it is a 0, what is it here? We get a 1, then again 0, then again 1. The same port was at 0 is becoming 1. This port was at 0 is becoming 1. Then to change from 0 to 1, it is taking some time. On its own, we are not changing. It was 0 perfectly. Yes, it is becoming 1. Same port if you are observing, same terminal if you are observing. Here it was a 0 that is becoming 1 on its own. I am not disturbing. So 0 is not stable. 0 is becoming 1 on its own. If it is 1, what is next one? 0, 1, 0. The 1 is becoming 0. The 1 is becoming 0 on its own. The 1 is also becoming 0 on its own. So 1 is also not stable. So 0 is becoming 1 on its own. 1 is becoming 0 on its own. So both 0 and 1 are not stable. It is named as a astable. It is named as a astable. Why am I discussing astable? You may understand. Yes. 0 is becoming 1 on its own, 0 is not stable. 1 is becoming 0 on its own, 1 is not stable. Both 0 and 1 are not stable, means it is a astable. Yes, 0 is becoming 1 in how much time? 1, 2, 3, 3 inverter delays. 1 is becoming 0 on its own in how much time? Again, 1, 2, 3 inverter delays. Yes, 0 is becoming 1 in 0 is becoming 1 in 3 inverter delays. Let me say that delta is inverter delay. Let me say it is 3 delta. Again, 1 is becoming 0 in how much time? 3 inverter delays. Again, 0 is becoming 1 in how much time? 3 inverter delays. Again, 1 is becoming 0 in 3 inverter delays. Again, 0 is becoming 1 in 3 inverter. Finally, what is it here? 0 is not stable. 1 is also not stable. Both 0 and 1 are unstable. So, if you are observing, it is astable, can be used as an oscillator. Oscillator can be used as a clock generation or clock generator. One by one, once again, what is it here? When I'm using 3 inverters, not only 3, it can be any odd number of inverters in this ring circuit is becoming astable. Astable can be used as oscillator because 0 to 1, 1 to 0, 0 to 1, 1 to 0. On its own, it is changing. That means 0 is not stable, 1 is not stable. So it is changing from 0 to 1, 1 to 0, 0 to 1, 1 to 0. That means it is a astable. It is a astable. Astable can be used as oscillator. Oscillator can be used as a clock generation or clock generator. What is the frequency of this oscillation, sir? Now I need to calculate a cycle duration. What is this here? On time is 3 delta. Off time is also 3 delta. So cycle duration is on time plus off time, 3 delta plus 3 delta. It is a 6 delta. And frequency is equals to 1 by T, 1 by 6 delta. For 3 inverters, how to calculate frequency of oscillations is 1 by 6 delta. If I have 5 inverters, then 1 by 10 delta. 1 by 10 delta. 1 by 2n delta. F equals to 1 by 2n delta. What is n? Number of inverters, which must be odd number of inverters. Right to understand point correctly? So when I'm using odd number of inverters in the ring circuit, it is becoming astable. Astable can be used as an oscillator. Oscillator can be used as a clock generator. What is the frequency of this clock? F equals to 1 by 2n delta. 1 by 2n delta. That means F equals to 1 by 2n delta. N is a number of inverters, which is must be always odd number of inverters. Odd number of inverters. There was a question in previous GATE exam. In the following circuit, each inverter delays 100 picoseconds. What is the frequency of output waveform V0? What is the frequency of output waveform V0? Once again, in this circuit, each inverter is taking 100 picoseconds. 100 picoseconds. What is the frequency of V0 in this circuit? Then F equals to 1 by 2 into 5 into delta is a 100 picoseconds. 1 by 1000 picoseconds is a 1 by 1 nanoseconds. Can be 1 gigahertz. 1 gigahertz. Answer is 1 gigahertz. I hope everyone can calculate that. Very simple. Yeah. Someone was asking me this question in logic gate itself. But I have my own sequence to convey the concepts. Let me follow my sequence. Every concept will be covered. No need to worry. Right? So I have my own order. Let me follow that. Let me follow that. Please. So you might be observing the logic gate question. But according to me, in sequential circuits, what is the frequency of this means? It's a clock. That's what my intention or my perception or my order. So let me follow my order because you will feel comfortable. Instead of worrying about question and answer, so to convey the concept, I need to follow an order. Let me follow my order. Please don't worry about that, where it should be covered and how it should be covered. So coverage, I will take care. Right? Understanding, please take care of yourself. So try to understand each and every concept which I've been conveying. Right? So don't be in hurry to learn everything in one day. It's not possible. So let us learn the concepts step by step. Then obviously you will get addiction of this subject. No doubt in that. You should feel that whenever you find a question, right? If it is digital question, let me try. Your mind should say that if you find a question somewhere you might be seeing a question. Yes, let me try this. I will get the answer. But generally, that opinion we will have, according to me, not for everyone. According to me, if there is an aptly question, it is common sense question, right? When there is an aptly question, always my mind says that let me try this common sense question. I can try. Maybe using different methods. Individuals may be using different methods, but finally everyone is able to try, or everyone maybe think that let me try. That opinion must be there on this subject also. That's what I'm expecting from student side. Once the course is done, then you should feel that when you see unknowingly you have seen a question. When you're talking to your friends also, there was a paper and there you have seen a question. Then your mind must think that, yes, what is that question? Because when we are understanding concepts, obviously your mind is willing to solve that question. That positive opinion must get after this coaching. That's what my intention. Please follow correctly. Every concept will be covered in depth. It's guaranteed. Wherever it is required, I am framing my own questions. I have been taking the previous questions also. So I will convey concepts in a right way. Please understand. Right. Yes. Yes, Pratyusha. Even I feel the same. Yeah. Nitesh has a doubt. Let me clarify the doubts. Right. In this circuit, instead of taking output at the last one, if I want to take a here output will be same. What is it here? You can push this inverter this side. What is there? Just a net. Just pushing that. Check it correctly. When I'm using that output here, that means after 4 inverters, it is not becoming bistable. Right? In this ring circuit, how many inverters are there? Where am I taking output doesn't matter, because it is just a cycle, or it is a, what we can say, repetition, right? So you can push this inverter this side, then obviously again we'll be getting same circuit. Whenever in this ring circuit I'm using even number of inverters, then it is becoming bistable. Not only 2, it can be 4, it can be any even number of inverters in the ring circuit, it is becoming bistable. Not only for 2, it can be 4 also, it becomes bistable in the ring circuit. Not the output at 4th output or 4th inverter output. No, the ring circuit is using how many inverters? Yes, 5 inverters. You may take output at first inverter output, or second or third or fourth, or whatever it be that. From here, it is again having 5 inverters. From here again, it is having 5 inverters. Like circular arrangements. You might have studied permutations, circular permutations. In a similar way, here also it is everywhere you can consider, wherever you consider, it will be stable, it is oscillating, frequency will be same. Frequency will be same. Are you there? That's what I've been explaining, Nitesh Kumar Yadav. Yes, it is circular arrangements. Every inverter is seeing back how many inverters? 5 inverters. Every inverter is seeing that. So it is, if you are looking back, you are having how many inverters? 5 inverters. It is 5 inverters. It is having 5 inverters. So no need to think it is becoming bistable at 4th inverter output. No. In this ring circuit, if you are having 4 inverters, obviously it becomes bistable. Not only 4, it can be 6, it can be 8, it can be even number of inverters. Here we have explained with 2 inverters, but instead of 2, you can have 4, or you can have any even number of inverters. It can be bistable. If you are using odd number of inverters, not only 3, it can be any number of inverters. If it is odd number of inverters, it is becoming unstable. It is oscillating, right? Sai Kumar, about duty cycle, that depends on how many inverters I'm using. What is the difference between rising time and falling time of each and every inverter? When we have that, then obviously we can find duty cycle also. So to calculate duty cycle, it must be known what is the rising time and falling time of each inverter. Yes, Gopal Krishna Reddy. Yes, sir. If you are using one inverter also, it is a stable only. Odd number, check it. So 0, 1, 0, 1, 0, 1, 0, 1, it is oscillating, right? Yugastri, I did not understand. Please wait for the question hour. I will help you, right? Sai Kumar, if your fate is not good, maybe there, but may not be. At this level, may not be, because in a designing level, yes, we ask question. And if it is industry training, if it is recruitment papers, there is a possibility for getting such questions. If it is industry training, or if there is a question in recruitment papers, yes, there is a possibility for getting such questions. Sai Kumar, it is possible. Yeah. Ashutosh, question is, if each inverter is taking 100 picoseconds, what is the frequency of output V naught? Question. If you are worrying about question is what is it here? In this circuit, if each inverter is taking 100 picoseconds, what is the frequency of output waveform? That is the question. Yes. When inverter delay is specified, I can calculate the frequency of oscillation by using F equals to 1 by 2n delta. N is the number of inverters. It can be odd number of inverters. So then only it can be oscillations. So the frequency of oscillation F equals to 1 by 2n delta. N is the number of inverters. It must be odd number of inverters. Odd number of inverters. Shivalila, please, you need to understand what is the need of feedback. Without feedback, is it possible to get a stable oscillator, even in analog circuits? Positive feedback is giving that a stable and working as an oscillator. You might have studied oscillators in which we are using positive feedback. Without using feedback, is it possible to get oscillations? Monica, when it is stable, where is the need of calculating frequency? Monica, if it is stable, 0 is stable. What is frequency? 0. It is DC. Is it changing to get a frequency? Please, Monica, please understand here. If it is stable, because when you are using even number of inverters, it is stable. Then what happens here? It is stable in 0. If it is stable in 0, means what is frequency? 0 frequency, because it is DC. Why do we need formula for calculating when we are using even number of inverters? Yes, yes, Arpit. I did not say Shubham Kurmate. I did not say that. I can use 7 also. I can use 7 also. I can use 9 also. I can use any number of odd number of inverters, depending on what frequency you are expecting. The frequency has to be changed. For a given technology, inverter delay is fixed. For example, inverter delay is fixed. Then what should I do? Calculating frequency. How to calculate frequency? F equals to 1 by 2n delta. But frequency must be modified. Then what should I do? I change the number of inverters. There is no limitation for that. Yes. I hope you might have understood the required things. What is it here? One, we are using bistable for memory element. Other one, we are using astable for clock generation. Now we are interested in this. So our interest is not clock generation, not only astable circuit for clock generation. We have so much is there. You might have studied that a PFD circuit, a charge pump circuit, voltage control oscillator, and a divide by network. That is a PLL, phase lock loop. Understanding? PLL we are using as a clock generator. In our processors, in our IC, we are using a PLL which is generating the clock. So there it is not only oscillator. Oscillator is one part, but we have other parts to control all other parameters like jitter and skew and so and so. So locking time, how much time it is taking to lock, even though there is disturbance, the disturbance again must be settled. Because of disturbance, it may be changing that clock periods that we say that jitter, cycle to cycle variation, we are saying jitter. So if there are any variations in the clock period, or if there is a positive jitter or negative jitter, then what happens here? We need to adjust all these. For that, it is taking some time. That is called locking time. So all that is analog PLL not required at this level. So clock generation is not only oscillator. We have so much. There is a connection with PLL. That is the reason I have given all this information, because that is my first project in TI, PLL design. That's the reason I'm able to say all this jitter and locking time and all these. So not required at this level, right? So understand this. So clock generation is not a simple concept to design. Yes, to design Manikanta Choni. I will give you. Wait, I will give you. Right? I'll give you expert. Wait. See, we have a bistable and astable, and bistable is used as a memory element. Astable we are using as a clock generator circuit. But in this memory element, can I use directly this as a memory element? No. Reason is it is capable of remembering 1-bit data. It is capable of remembering 1-bit data. But where should I feed the information in this? Is there any input terminal to feed the information? We don't have any input terminal to feed the data which I would like to store in this memory element. This memory element is capable of remembering 1-bit data. But if I give it can remember, but where should I give that input data? Is not possible in this circuit. That is the reason we need to have input terminals. So memory element means not only remembering, it must be having other functions also. What is that here? It must be allowing us to modify the data to 0. It must be allowing us to modify data to 1. Irrespective of existing, I must be in a position to feed my own data, which I would like to store in this memory element. So memory element means not only remembering. Yes, it is remembering if it is given, but to give, there must be input terminals, or there must be feasibility for modifying the contents of memory element. There must be feasibility to modify the contents of memory element. I hope you are following. So what we are expecting here, there must be feasibility for modifying the contents of memory element. For that, we should have external inputs. We should have external inputs. Correct? Are you following? See, instead of using inverters, I need to use other logic gates which are giving external inputs also. So finally, what is the conclusion? A circuit which is capable of remembering 1-bit data is called 1-bit memory element. This is capable of remembering, but it is not allowing us to modify the contents of memory element. There are no inputs, or there are no input terminals to modify the contents of memory element. To get that feasibility, in place of inverters, we can use other gates which are NOR gates and NAND gates, which are giving feasibility of remembering, which are giving feasibility of modifying contents to 0, which are giving feasibility to content to change the contents to logic 1 also. Then what we can say here, I can use instead of inverters, I can use either NOR gates or NAND gates. First, let us see one by one. I'm using first NOR gates. I'm using NOR gate. If I say here we have a AB and here it is X and Y. AB, X and Y. So what we are observing here, this is also can work as a memory element conditionally. What is that condition? Let us see. So for each and every input condition, let us see what is the functionality of this memory element. First of all, what functions you are expecting from a memory element? It must be remembering. It must be allowing us to modify to 0. It must be allowing us to modify the contents to logic 1. So each and every input condition AB, if you are verifying, each and every input condition of AB, if you are verifying, what is the input conditions for remembering, what is the input conditions to modify the contents, we are seeing one by one. We are going to see one by one. Let us see once again. What is it here? This is NOR-based memory element. This is NOR-based memory element. If I use A, B, X, Y. And already we know that NOR gate functionality. Understood correctly? If one input is 0, what is that output? 0 plus P whole bar, it is P bar. For this NOR gate, if one input is 1, irrespective of other input, what is the output? 0. You need to understand here importance of what we have discussed in logic gates. Enable input and disable input. Logic 0 is enable input. Output is depending on other input. Output is complement of other input. When one input is 1, gate is disabled for other input. Irrespective of other input, output is 0. These concepts will help us in analyzing this logic circuit. Be clear. So I'm mentioning here the importance of enable and disable inputs. Now we are utilizing. Already we have discussed each and every logic gate enable and disable input. Simply you might have thought, why? What is need of this? Yes, those concepts only will help us in understanding this memory element now. So NOR-based memory element I'm analyzing now. For each and every combination of AB, what is its functionality? Let us verify. So if I use AB or 0, 0, if one input is 0 for NOR gate, what is the output of NOR gate? Complement of other input. Complement of other input. For this NOR gate, one input is 0, other input is what? Y. So output is complement of other input. Any doubt in that? For this NOR gate, one input is 0, other input is Y. What is the output? Complement of other input. Yes, output is Y bar. Similarly, for this NOR gate also, if one input is 0, what is the output? Complement of other input. What is other input here? X. So Y equals to X bar. Y equals to X bar. Once again, for this NOR gate, one input is 0, output is complement of other input. Yes. So for this NOR gate, other input is what? Y. So X equals to Y bar. For this NOR gate, one input is 0. Yes, output is complement of other input. What is other input here? X. Y equals to X bar. Let me substitute Y equals to X bar here. X bar whole bar is equals to X. So X equals to what? Y bar. Again bar, it is equals to Y. That means it is remaining in the same.